So once again, we're going to use the hydrogen peroxide. So hydrogen peroxide, again, H2O2, decomposes naturally over time. Okay? Why the brown bottle? Sunlight, yeah. What's the sunlight do to it? Breaks it down faster, yeah, because the energy come off the light. Not only sunlight, but even fluorescent lighting, that kind of stuff, is going to cause that to break down faster. So the brown bottles helps it store longer because people buy it, put it in their bathrooms, and it sits there for, several months. If you have something in your bathroom that is 3-4 years old, it's time to replace it. It's still going to be kind of out of speed at that point. So we're going to add about 50 to 100 milliliters of this stuff in here.
Why does it come out so slow?
So we are just over 50, which is plenty for doing this demonstration. And again, we have the accordion bottle because it naturally decomposes. So as it decomposes, it's producing oxygen gas, which would pressurize it if we didn't have this, but instead it actually allows it to flex so it doesn't gain pressure. So that's why the bottle looks kind of goofy like that. Now, on its own, it's decomposing. That is it, okay? Very slow, very boring. So we want to catalyze this. We want to speed it up, okay? So our catalyst we're going to use is 2 molar Ki, okay, or potassium iodide as our catalyst. We're going to put some visual effects in this thing too. So first thing I'm going to do is I'm going to add a little bit of food coloring. And the food coloring is not going to do anything to the chemistry, it's just there for visual. And I'm going to add some soap. Again, the soap does nothing to the chemistry, it's just for our visual to make it a little bit more entertaining. Add a little soap in there. So again, it's still decomposing, so now we're going to catalyze it. Adding in our Ki. You'll see why I call this elephant toothpaste.
I want to touch it.
Eat it, go taste it.
Alright, so again, pretty quick, the soap kind of slows it down a little bit. And then if I take a lighter to it, and normally you would think, a lighter in the foam, usually a foam would put out the flame, but if we put a lighter on it, it just kind of eats right through it, so it doesn't actually take the flame out. It actually allows the flame to keep burning. So why does it keep burning? Oxygen, because our gas is getting off here is oxygen gas, so the foam is really highly concentrated oxygen gas. So that's what we get, okay? Which is hydrogen peroxide. Peroxides are a weird chemical. They're actually oxygen and hydrogen. Oxygen in this case is actually a -1 charge. It's a rare case where it does this. But when it does, it always still comes in pairs, so that's why you see the H2O2 on here. This was 30%, so if it was 30%, what state of matter was it in? Okay, so if it was liquid, why would we say 30%? It's mixed with water, so it's not a liquid, it's a solution, right? Yeah, homogeneous mixture solution. So anytime you get a percentage or a parts per million or a molarity or something that tells you that it's not pure and it's in a liquid form, probably not really a liquid, it's probably actually in solution. So we have H2O2 and it's in solution, so we designate that by aqueous. It's our only reactant, because it's a decomposition reaction. But what goes above the arrow? The catalyst, which in our case was the Ki. And then we made water, and we made oxygen. What state of matter was the oxygen in? Yeah, it came out as a gas. And the water, probably a little bit of mix of both, but primarily it stayed in its liquid form. So we have liquid there on that. Now what else was produced from this? heat. So if heat was also produced, we can use a triangle to symbolize that. So exothermic or endothermic reaction? Exothermic reaction, okay? Is this balanced? No, we haven't talked about balancing equations yet. That's actually the video you're gonna watch tonight, or actually sometime before Monday. But to balance this, you wanna make sure it's the same on both sides. So we wouldn't have to double this and double that, okay?